Magandang araw. Ako si Kuya Code. Welcome back to my channel where I teach Python programming through Hackerrank problems. We're going to go ahead and continue with these math ones. These are pretty simple, so I'm just going to throw them all into one video. So let me open these up here. The first one is the modulo operator, which I've used before. I'll just go into a tiny bit more detail with those. For this is about integers and how in Python integers are different in terms of the max capacity compared to like C or Java or C++ or any of those kind of languages. And this is just simply power, like 2 to the power of 3 and how that works. So let me go ahead and open this up here. So normally if you have two integers and you do division, like A equals 10 and B equals 3, but then if you print A divided by B, this gives us 3, and the answer would be 3.3 repeating, but because it's an integer, it chops off the end, because it converts it to an integer. Of course, if I go ahead and do a single slash, it makes it into a float, which shows what the proper answer is. Of course, it's just going to put a 5 instead of doing this to infinity. But what you do with the modulo operator is it will give you the integer answer, but also show the remainder. Sorry, it'll only show you the remainder and not the integer answer. So what you could do generally is this. So this first part will just chop off the end and show only the integer portion, and then this part will show you the remainder. So if we go ahead and run that, well, 10 divided by 3 is 3 remainder 1. So simply enough, that's the integer. So that's the modulo operator in this case. So what we can also do, just with some more examples, we can just print, again, if you do 10 modulo 3, that returns, or that outputs, prints 1 with 1 remainder. This one, like, let's say do 20 modulo 4. Well, 20 divided by 4 is evenly into 5, so that's going to print 0. And this one, let's say 15 modulo 6. This is going to output 3. Because obviously 15 divided by 6 ends up being 12 with remainder 3. So yeah, there's 3. So next is the powers. Actually, well, here's an easy example of the most common case that I could think of where this is used. So if you have number equals 7 and you want to find out if it's even or odd, if num modulo 2 is equal to 0, then print even. If I can type. And then else print odd. Apparently I can't type. So because 7 modulo 2 would give us, because obviously 7 divided by 2 is 3 remainder 1, the remainder is not 0, the remainder is 1. So this is going to give us 1, and so this is going to be false, which means it's going to simply go into an odd. I need my semicolon. It's going to go ahead and tell us that it's an odd number. And of course, if it was 6, then it would give us an even number. And of course, you can do that with any number, really. You can just do like this and do that. Even though this isn't really realistic, but it's odd because these numbers aren't evenly divisible. I'll show you another example that's really useful with modulo and how it relates to Pygame. On the side of this, I've been kind of messing around with Pygame a little bit as well to make just some 2D games and different things. So next thing we're going to do is just go over powers. This is also pretty simple. So if I print, you can do it 2 ways, 2 to the power of 3. If you just do with 1 star, it's 2 times 3. Which would give us, actually I can just do it both ways. Print 2 times 3. Close, reopen. So 2 times 3 is 6, 2 to the power of 3 is 8. And you can also do it this way. I think I need to import math. Let me just check. We can do print power and then just do 2 comma 3. That should also give us 8. Yep, that also gives us 8. It says the same thing. We actually also can put a third parameter in here. So let's say 2 and 10, and then 1000. This actually will give us 24, because if you just do it like this, 2 to the power of 10 is 24, but because we have this is actually modulo as well. The third parameter is modulo, so obviously if you have 24 divided by, or 1024 divided by 1000, you'll have 0, or you'll have 1, remainder 24, which is why it gives us 24. And one other thing is it's actually much faster to do it this way. Let me just show you actually. Print. Let's do some giant number. And this actually relates to the third problem of integers with Python don't have a max limit. If I were to do a max in C++ or Java, what you get basically 2 to the power of, if it's a, well, let's just do C++ because there's something called a signed and an unsigned. Signed means that the first slot in the bits are reserved for whether it's positive or negative. So if you have a 32-bit integer, the first one would be whether it's positive or negative, so you only have 31 bits remaining. So therefore, if you do it like this, 2 to the power of 31, that is completely wrong because I brought the power. 2 to the power of 31 is 2.147 billion, and funny enough, there's a game called RuneScape, and the max cache stack was exactly this because they used a 32-bit integer. But this is because, as I said, there's positive and negative numbers. So in C++, if you have a unsigned, which means you don't have a digit to say whether it's positive or negative, in that case, all the digits are, it's only possible to be a positive number, so you actually have 32 for that. So that gives us twice the amount. So like I said, this is the maximum size or the maximum value an integer can hold in like C++. But with Python, there is no max. So if I do 256 and like 7, it ends up being some like crazy high number. In Java, there is a class called big integer, which would kind of give it the same result, but Python just has it by itself. And this could be like stupidly big. As you can see, it's probably, yeah, like I said, it's just giant number. But my computer's so fast that it still computes it. But I guess my main point is that if you take this and then do modulo, let's say 9, compared to 7 to 56, 9. They both give the same result, but doing it this way is actually faster than doing this first, giving some giant number, and then doing another calculation after that to get the modulo. So even though these do give the same results, this way is a bit faster. So one more quick example regarding the module that I think is kind of cool. So I'll have to import math and import time. So if I open up my drawing, oops, that's not what I wanted to do. Imagine you have a top-down shooter, like a 2D top-down shooter, and you have your character where you can move around, but you also have 2 buttons to rotate the character. So let's just draw up, this is the player. The player is looking this direction, and let's say you're using the left and the right arrow keys to actually rotate the player. So if you start pressing right, you'll rotate to the right. So after a certain amount of time, it'll be facing this way. Keep rotating, eventually it'll be facing this way, and you can kind of go all the way around, which is basically 360 degrees. And if you press left, they'll stop rotating clockwise and start rotating counterclockwise. So how you would do that in Python, or sorry, in Pygame, is if, let's say you have an angle, starts at 0, rotation speed. So this is just like how many units you're going to rotate for every tick or every frame of the actual game. So we'll just do math dot radians. Let's just put in 30. So that means every frame you're going to rotate by 30 radians. And radians is kind of similar to degrees. and how it relates to circles. So just for this demonstration, I'm obviously not going to have Pygame here. I'm just going to show you an example with a loop to kind of simulate it. So for underscore in range 15, let's say there's going to be 15 different increments of a character rotating clockwise. We normally would do angle plus equals rotation speed, and then angle in degrees equals math dot degrees. You pass in the angle, and then we'll go ahead and print that out. We'll just print out like that, and then we'll just do time dot sleep by 1 second, just so you can actually see it do it in slow motion. I made a typo. So imagine this is the angle or the in degrees of the character rotating. Of course, if you rotate once, it's 360. The problem is, as you can see, that it continues to go past 360, which when you take this number and you use a different piece of code that actually physically translates or rotates the image, which is the player, it's not going to really work if you say 450 degrees, or maybe it will, but this is what we would normally do to kind of make it a bit easier just in case it doesn't work, because I don't remember off the top of my head. But we'll do normalize normal angle equals angle in degrees modulo and then 360. So again, you're going to take that number and divide that by 360, and it's going to always give you a number between 0 and 360. So we'll do it a bit faster this time. So if I do it again, it's going to keep on going, keep on rotating, and as soon as it gets to 360, I didn't actually type the normalized one. Let me go ahead and actually print out the normalized one. Do it again. Rotating, rotating, rotating. And 360, and then it just restarts because it already made a full rotation. So obviously if you get to basically 360 and you keep rotating, you're going to reset back down to 0, and you're just going to continue again. So that's a kind of a practical way of how you would use the modulo operator. It is useful for checking things like whether a number is even or odd or whatever. But in this case, it's something more practical to use in making a game in Pygame. So that's pretty straightforward. So let me go ahead and just go to these. Like I said, these are pretty easy. So in this case, we're given 177 and divided by 10. When you make it into an integer, it's going to give you 17 because it's going to cut off that decimal, and then the remainder is the 7 there. So just like in the other example, we'll do a input like that, and then we'll just, there's A, there's B, and then we're going to print A divided by B, which will give us the integer. So normally if you do 177 divided by 10, it's going to turn it into this, which is a float. But if we only have if we have 2 slashes, it's going to make it an integer. So this gets deleted, which gives us a 17. And then we also need the 7. So we're just going to do this with the modulo. That'll give us a 7. And this is kind of like a tuple. So you would just, where you would do that, the first part and the second part. So this would be A divided by B, comma A, modulo B. Go ahead and run that. Yeah, that's simply enough. Go ahead and submit that. All right, that one is good. And now we'll go over to the powers. This one uses the power method that we have had before. So I'll go ahead and do this. Oopsie. A equals int input In this case, you're taking one example. You have a and b, which is a to the power of b, which is basically the same thing as doing that. But also this other option you have, you're including the modulo as a third parameter here. So you get three numbers, which we have a, b, and m, and then 3 to the power of 4 is 81, but 3 to the power of 4 modulo 5 is 1, because when you have 81 and you divide that by 5, you're going to have one remainder. So we can just print A, B, and then this would be, let's just do like this, so we can have the three options here, A, B, M. Run that. Okay, that is good. Okay, that one is also successful. And lastly, we'll just do this one, which just has you print out a giant number that would normally be way too big for an integer. So like it says here, there's in integers in Python can be as big as the bytes in your machine's memory. There's no limit to size. Normally, like I said, 2 to the power of 31 is a signed in C++, or 2 to the power of 63 is a long. And then if this was unsigned, it'd be 32, and if this was unsigned, it would be 64, which is kind of where we got, 32-bit and 64-bit for, operating systems. So for this one, we have 4 parameters. So we have A, B, C, and D. So A equals int input A, B, C, and D. And then we have to, let's see here. Oh, A power of B plus C to the power of D. So A to the power of B plus C to the power of D. I'm probably going to need to have brackets here, or else it's going to try to do... Actually, no. It should do order of operations, since you got to do the exponents first. Yep, so we're good to go with that. And that one should also work for submit. Don't know why this is taking its time. All right, we are good to go. So it's kind of a shame that the math section was so short, just because I like math, but I'm sure there'll probably be more opportunities to do math in some of the other problems. Well, actually, if I go back to unsolved math, there is 3 more medium problems that I'll do another time. But that's it for this video. Please like and subscribe if you found this helpful, and let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Bye, Alam.